TTL Computer 2. Today we'll be taking a look at our final schematic for our main build out of our computer, and that's going to be the backplane. And we're going to start out today looking at our digital simulation to set the stage for what we're going to be looking at in our schematics. So this should be familiar. So here's our main elements that are on our going to be on our back plane, right? We have our left and our right bus. We have our address bus, our data bus. We have our control bus, uh, and our clock signals as well as power. And then we have our reset circuit that we looked at recently, and also our hex display. So those are the elements that are going to be on our back plane. But let's look at some of the elements that are indirectly going to be on our back plane. Okay, so these are our cards, right? So these cards are going to plug into our back plane. Our clock, our ALU, our control PCB, our memory card, our registered card, our memory address register card, and our program counter card. So this is kind of like where we ended our digital simulation, our logical design work before we jumped off into our schematic work. And we kind of ended, if you remember, kind of discussing about making some decisions about the card level interfaces. And one of the things that we could have done was made every single card slot be exactly the same, so that we would have every signal control line, being on every card level interface and in the exact same position on the card level interface. And I kind of decided not to go that way. And the reason why I didn't go that way was because, hey, this is my first experience doing PC board design, and I was really concerned that I'd be having, complexity that I couldn't deal with at the card level with having all of those control lines on every card level interface. So I didn't go that way. So I kind of made the decision that, each of the card level interfaces for each card is kind of going to be, potentially unique. And again, the main driver there was, since I was going to have a smaller number of controls per card, that the routing on that individual card would be simplified. And I wanted to go that way because the card level designing was just a big unknown to me. So that's kind of like you know leads into the schematic design. But one of the thing that means that we kind of left uncompleted or unfully analyzed or unfully rationalized, the positioning of all of the controls on the individual cards. We really didn't fully complete that at this logical design level. Okay, so let's jump off into the schematic now. So first thing you can see is that our schematic, we have quite a lot of pages in our schematic. We have bus level schematics, we have main connection schematics, we have expansion schematic, we have a passives and an active element schematics. So there's a lot here. And this was by far the most complicated design that I had to do, of all of the cards is the backplane here. So um, so this is our clock card. This was the first card that we did, and this kind of defined our initial card level interface. We said that power and ground were going to be here on every single card edge. And we also said that every single card edge would have the main clock signals be in this standard location. So, right, not clock, we have not clear rather, not clock, P clock, U clock, and T clock. And we have ground level connections between each of those pins just to help with signal integrity. So that was something that we said was going to be standard, and I did follow that through with each of the card edges. We can see that, power is at the top, and these are the clock signals and the clear signals here. Now, what I should have done, and what I think I probably did in the beginning, was I physically copied this out to each card edge and dropped it in. Somewhere along the way, I stopped doing that because it felt like it was just extra work. And what I started doing was I noted the pin numbers. And when I got to doing the schematic here, I noticed I made a mistake. So if you see here, C10 should be a ground connection. And somewhere along the way, I made an error and I started using C10 uh, as a pin for signals. And that technically is an error. It should have been ground line on every card edge connector. It's not a big deal. It's not causing us a problem. We're not having any wiring issues per se, but it just means that on some of the cards, C10 is a ground, and on some of the cards, right, C10 is no connection here. Oops. C10 is a signal here, and whoops, rather, C10 is not connection here. See, C10 is a signal here. Technically shouldn't be that way. So that was one of my first errors that I found as I went into bringing everything together, bringing all the card edge connectors together. So that was a first error. The next item was, I started out here with the connections. I brought in all of the connectors together, and you start to see a potential issue here with, again, dealing with decisions that we made. Right, we said here the data bus connections are here on this card, but the data bus connections are here on this card. A0 to 15 is here on this card. The address pins are here on this card. So you can see, we start to have issues like that where the cards were not all completely standardized. Our data bus is here on this card. Now we have L0 to L7 here. Right now we have, again, the data bus is here on this card. We have our left bus now is over here in this card, and our right bus is here where the left bus was before. So we're really just having, potential issues or complications with the decisions that we made. So I chose to err on the side of, simplifying the card level routing, but now I'm having to deal with complexities in the backplane routing because all of these pins on each card edge are not in the same place. So those are two of the first, complications that we had. One, I made that error with that C10 pin, not making the control signals all be completely identical on each card. And then the control signals not being in the same place on each card edge. So those were the first two complexities that I encountered. All right, that's going over to expansion cards. So these are all our cards, right? These 7 cards make up our computer, and the primary 7 slots on our backplane. I also wanted to include, expansion slots, and I chose to include 3 expansion slots. And the good news is that once we get to the expansion slots, these are all standardized now, right? We have the data bus and then the address bus. We have our read and our write signals here, and our U clock signal. So each expansion slot is standardized and is the same. So the reasoning behind 3 is that this will probably be one slot for our serial I/O. This will be one slot for a memory expansion card, and this will be one slot probably for a video card. So that's my intention now. This could also be used, this slot could also be used to daisy chain into an expansion bus that would have more expansion slots if needed, but I don't I don't think we'll have to go that way. All right, so those are our bus connections on our backplane. Now looking at our passive elements, right? We have our decoupling capacitors for some of the active elements on our card and the power supply as well. We have 3 power decoupling capacitors. We have our power indicator for the motherboard, and then we have our power connector for our motherboard. And we're also including here is a resettable 6-amp fuse. So I've done some estimation on what the power draw for the whole computer is going to be, and it's going to be about 4.5 amps is my estimate. And with the cards that we have installed, and therefore we're going to use a 6-amp resettable fuse to protect the computer. Okay, those are our passive elements. Our active elements, we have our reset circuit here, which is virtually identical to the circuit that we looked at in one of our videos, and as well as on the backplane review. This circuit is essentially identical. We have our reset switch here, and I'm also including a header here. And what that header, a 2-pin header, and this header is just going to allow us to pull out an extra reset switch to the future case that this computer is going to live in. So, this reset switch is going to be on the backplane, but this will give us a header where we can, pull out another reset switch in parallel to this one that will be on our case, whatever the case is for the computer. Okay, and then this is our hex display, and again, this is virtually identical to our logical simulator design, right? We have our low and our high bits of the TTL 311 hex digit displays. Okay, and that brings us to our last sheet in our schematic, which is all of our buses. Now, one of the other things that I had to make a decision on was how we were going to support testing on the backplane. So we had our testing jig to individually test all of the cards, and I wanted to have a way to validate the backplane, right? Do unit testing on the backplane before we plug in our cards to the backplane. So I went back and forth on different ways to do that. Could have used, had some testing pads on the backplane. I could have had some switches on the backplane, but what I decided to do was to provide a breakout header for each of our buses. So, here is our left bus. There's going to be a left bus pin header that we can plug into. Right bus, right bus pin header. Right, our address bus, 0 through 15. We have 0 through 15. We're going to have breakout headers. Our data bus, and we'll have a pin header breakout header for that. Right now we get to our control signals, all of our control signals, breakout header, breakout header. This is our not memory out signal. I don't know if we really spoke about this a little bit, but this again, if you remember, is I wanted to provide uh, a forward path for a direct memory access. So we need a signal that will turn off the memory address register from driving the address bus. So that's what this signal is. And we have also a breakout header for that. We have the rest of our control signals with breakout headers, and we have our clock signals, T clock, U clock, P clock, and not clock with breakout signals for those. And then also this last breakout header is to provide is a breakout header for the control signals on our expansion card. Okay, so I think that fully fleshes out all of our schematics. You can see there's quite a lot going on. Again, so we have our buses, we have our card edge connectors, we have our three expansion connectors, we have our passive elements, and our active elements. So we have all those sheets need to be pulled together. All these sheets need to be pulled together into our PC board design. And you can see that there's quite a lot that we're going to have to design and fit on one signal board and do all of the routing and to try and get that all accomplished in a two-layer PC board, which is what we've been doing. So that's quite a tall order for a beginning PC board designer, but that is what we need to do. And we'll take a look at that and we'll take a look at some of the issues we had there and some of my solutions for those issues in our next video when we take a look at the design of our final PC board for our main build out, our backplane PC board. So that's it for today. Until next time, thanks for watching.